Expression for capacitance of the system of two plates where one of the plate is tilted up by an angle theta. So this is what you are seeing, a picture where one of the plate in the system of capacitor is tilted up, making an angle theta with the horizontal. The left separation between the plates is at D, and the length of the plate is A, whereas the width is B. So now we have to find an expression for such a kind of a system of two plates having capacitance something, say C. Okay, so for this what we have to do first is we know the expression for capacitance. So expression for capacitance by definition, what we write? By definition we write C is equals epsilon O into A divided by D. This is the formula what we usually use to mention the capacitance of any parallel plate capacitor. But here the distance between the two plates is not fixed, whereas when you move from left to right, the distance between the two plates goes on increasing continuously. So in such a kind of one situation, we cannot use this equation directly. We have to manipulate this equation. Let us see how it can be done. For that, I suggest you to mark a small area element somewhere here. See this one. This is the area element we are simply choosing, and this area element is dA, whose mapping is on this plate also, like this. This is the mapping of the same area here on the bottom plate, and this is also having the same area dA. Now at this position, the length, this height, we say this distance between the two plates here is y. Okay, so this is y. So now we have to get an expression for this y. That becomes the distance between the two plates at this position of the area element. Okay, for this situation, what we can write is the area of the element, dA is equals, what I can write, it is of width dx. Okay, the width of this area element, this is dx, and the breadth is b, already said. So this becomes b into dx. This is the width of this area. Okay, so area of this much value is here as well as here. So area element is now, and what is the distance between the two plates? It is y. So we have to do something for this y now. So what it can be done here? See, let us write an expression for this line at this position. Okay, say this distance, which is measured from this edge to this position, is x. Okay, so this distance is x. At that moment, what I can write is expression for y is equal to what? Actually we write y, it is a straight line here what we are seeing at this edge. This is just like mx plus c, right? It is y is equals mx plus c. What actually m is nothing but slope of this particular graph. That means this line. So let me say at one edge we are having something parameter which is said beta or something, which is here, right? I am simply calling it as a beta. So what actually this theta here now? So we have to find this one, that is what I can write, use tan theta, and tan theta is nothing but our slope, right, which is equal to what I can write, it is opposite segment, which is beta. And what is this? Is this length is in total, it is a. Okay, so from this end to this end, the edge length is a. I should use that term a here. So if in future, if I say if theta is said very small, then I can simply say theta is approximately equal to, it is beta divided by A. It is only this much. Theta is equals to beta divided by A. I can make use of this situation later. So now what we have to do is, in this particular situation, I have to write something for C also, which is here, right? C is y interception, right? So this is y interception at x is equals 0. So this is the position where x is equals 0, right? So at x is equals 0, what is y? Because we are treating x-axis along this line and y-axis along this line. Okay, so at this position, the value of y is this much, right? So from here to here. So at this position, so what I can write is, C is equals D. Okay, so C becomes a D. Therefore, what I can write for y, so y is equals, m is simply, it is beta divided by A, otherwise I can simply make use theta. If I say this is a very small, right? If theta is very small, I can simply make use of theta here. Theta into x, let me keep that x as it is, plus what actually C is D, which is said here, right? Y interception, which is D. Now, for this one, the capacitance of the capacitor of this element. Now, capacitance of the element is dc is equals, I can simply make use of this term, dc is equals epsilon O into dA divided by this is y, because we are not using the term d here. This element, these two elements, right, this area and this area are separated by a distance y. So instead of d I must use y, and the area element is of value dA. It should be used. So now let me make some substitutions further. That is, dc is equals, the element capacitance dc is equals epsilon O. What actually dA is? So dA is already written somewhere here, which is b dx, right, divided by y. What actually y is? Y is this much, which is theta x plus d, right? Otherwise I can rewrite this also in a different way. Now I simply take out the term d just for some simplicity. Otherwise I write it like this, epsilon O b divided by d, and here it is 1 divided by 1 plus theta divided by d into x. This is how we can rewrite, multiplied by dx. Okay, let me take this denominator into the numerator. So which becomes like this, so which implies dc is equal to epsilon O into A divided by d. It is 1 plus theta divided by d into x to the power minus 1 into dx. Now I simply make use of binomial theorem here, right? So apply binomial expansion, and neglect higher order terms. If we do so, at that moment we get 1 plus theta divided by d x raised to minus 1 is approximately equal to, okay, so it is approximately equal to 1 minus, it is theta divided by d into x. This is what we may get in place of this. So then simply write this one in this place. Therefore the area capacitance is, elemental capacitance is epsilon O into A divided by d, and instead of this one, now I am writing this thing, which is 1 minus theta divided by d into x into dx. Okay, so this is the capacitance of the element. Okay, it's only for this element. Now the capacitance of the complete system. Now capacitance of the complete system is C is equals integration of dc. Since this length is increasing in distance between the two plates continuously, we have to integrate it like this. Okay, so this is equal to integration of these things, which is epsilon O into A divided by D, and inside bracket it is 1 minus theta divided by D into x dx, and we should know the limits. See, x is the variable what we already known. So x varies from 0 to this position. At this position x will take a value a. So we should integrate this x from 0 to a. So that is what we have to apply here. So x is from 0 to a. When I do that, definitely this is equal to, I can keep something outside, which is this much, right? Epsilon O into a. So what actually that a is? That a is nothing but something somewhere we made it wrong, right? So which is somewhere here I made the mistake. It should be b, right? It should be b. I should make it clear, right? The term is b here. It is not a. It is b divided by d, and here what I have to put, it should be made integrated, right? X is equals to 0 to x is equals to a. What the term left, it is 1 minus theta divided by d into x. So into dx. And finally, I have to write the result of this. Therefore, C is equal to, right? C is equal to, what I can make? I can simply write C is equals, it is epsilon O into B divided by D. And in this result, now we get, it is x minus theta divided by d, it is x square divided by 2, and with the limits x is equals a, I mean 0 to x is equals a, right? X is equals 0 to x is equals a. So definitely what I get simply C is equals epsilon O into B divided by D, and in the bracket it is when I put the values of x, lower limit is 0 luckily. So that means when I put lower limit, so I get 0 here, and when I put upper limit it will be a minus, right, a theta x a square, theta a square, right, theta a square divided by 2d, right, this much. And when I take a as common, this will be C is equals epsilon O AB divided by D, right, divided by D, and inside the bracket what I may get, it is 1 minus it is theta into A divided by 2D. So this is the value what I finally get, and this is the capacitance of this system of two capacitors in first method. I am calling this first method because you can also get the same answer in a different way that I am showing in the next sheet. Okay, so this is how I can achieve that answer. And next what I am doing is I am simply showing you something like this. Here what I am doing, I am making use of the same equation, the method 2 I am showing you. Okay, so method 2, I am simply using the same equation, which is dc is equals epsilon O dA divided by y, right? So here dc is equal to what it is, epsilon O to dA divided by y. Now I make substitutions like this. What actually y is equals theta x plus d, right? Here y is equals, right, it is theta x plus d. But what is this theta? Theta stands for slope, right? Now I am not using this here as theta, and simply use it as m, that is slope. So that means what it happens here, instead of using theta, if I use m, so m is beta divided by a, right? So which implies what I can write, y is equals, it is beta divided by a into x plus d. This is what I can write. So this is y. And nothing happens to a, which is bdx. Therefore, what I can write for dc, dc is equals epsilon o b into dx divided by y is this much, which is beta divided by a into x plus d is what I can write. And now I can simply take out d as common again. Of course, I can take it. Otherwise, let me leave it as it is also. And when I make the integration, this is the capacitance of element. Capacitance of the element. That means only for this much. Okay, this value holds only for this much. And for complete capacitance and for total system, system, what we have to do? We have to integrate this, right? So when I make the integration, this will be, epsilon o into b remains a constant outside integration. This is a integration of dx divided by, it is beta divided by ax plus d, and again x varies from 0 to a. Well, when I make this integration possible, that is what I may get, c is equals to epsilon o b, right? The integration will yield a result like this, into 1 divided by beta by a, right? Beta by a, and natural log of beta divided by a into x plus d, and don't forget the limits 0 to a. So that means when I rearrange this, okay, so when I make rearrangement, beta divided by a is here, right? I can simply take this a up. C is equals, it is epsilon o b into a divided by beta, right, into this one, which is natural log. When I make the substitution for upper limit, what I may get? I may get, it is beta divided by a into a, right, plus what is d? Let it be d as it is, minus, when I put lower limit, it will be natural log of, it is 0 plus d. Okay, so further what I can rewrite, it is c is equals epsilon o b into a divided by, but beta is what actually? So beta is, we can rewrite from here, beta is, if I again use theta is very less, then what I can write, it is nothing but a into theta, because I am assuming theta is very small here. Okay, theta is very small. So now I am using the term a theta here in place of beta, and in the brackets what happens, it is a natural log, it is beta, so beta is a theta because a term get cancelled, plus d, right? So that much, which is here, one term of a get cancelled, and we get again a into theta plus d, right? Next what I get, I get something like this. Here this is nothing but minus, right, natural log d. Okay, this is equal to epsilon o b a divided by a theta, and here what I can write, it is natural log of a theta plus d divided by d. And when I split the new denominator for both the numerators, epsilon o ba divided by a theta, and it becomes a natural log of 1 plus, right, it is a theta divided by d into a. So this is what I got. And when you make the expansion of this, so expanding expanding natural log of 1 plus theta divided by d into A. So which will yield an approximation of it is theta divided by d into A minus it is a half of theta square d square A square. So this is an approximation of the expansion of natural log of this much. So when I use this one here in the place of the actual equation, so C is equals epsilon O B into A divided by A theta, and here I can simply use theta divided by D into A minus it is theta square A square divided by 2D square. So now take theta into A divided by D as common, right, as common. Then I get C is equals epsilon OBA A theta, and what I am taking out theta A divided by D outside. So I get 1 minus theta divided by 2D into A inside bracket. So here the terms like A get cancelled and theta get cancelled, right. So the remaining terms are C is equals epsilon O. Be careful, here is A and here is B. AB divided by, here it is D, and inside bracket what I left with, which is 1 minus theta divided by 2D into A. So I got this much result, which is exactly same as this one what we already got in first method, epsilon O AB divided by D into 1 minus theta A divided by 2D. So this is the capacitance of this system what we shown here, where one of the plate is tilted up.